Okay, so yes, classifying numbers. Rationals is one of the things. Imaginary is one of the things. Irrational is one of the. So do you know where those titles go? Like you're naming all the right things. Integers goes in there as well. Rationals would be this one.
Because all real numbers are at the top.
Because real is at the top. That's right. So real numbers include rational and.
There's imaginary little box and stuff.
Yeah, look at that line separates them.
Yep, imaginary is this box over here. Right? Real versus imaginary. That sounds like those would be opposites.
It includes rational and irrational.
Real includes rational and irrational. That's true. Kind of.
Yeah.
Okay, what'd you say?
Pi.
Pi would be irrational. Irrational would be anything that can't be written as a ratio. Right? It'd almost be better if we pronounce these as ratio nulls. That sounds funny, but that's what rational numbers are. Anything that can be written as a ratio. And irrational would be anything that can't be written as a ratio. A ratio of integers. So, you tell me, what's integers is the next rung down here. And then it is whole numbers.
And then it's counting. How did I remember counting numbers?
Counting numbers
I think we did this in like 6th grade.
or natural numbers.
Oh yeah, natural. That's
Natural.
Either one. Counting is nice because that's pretty descriptive of what it is, right? When you're counting, you start at 1.
Right? Oh, it says everything that doesn't include 0. Yeah.
The whole numbers include
0.
the whole, 0.
And then integers is everything else.
It's negative.
Negative. Right?
Well, negative, but no fractions, so
No, fraction is rational.
-3, -2, -1. This is kind of weird the way I wrote that. The negatives on the left, the ... on the left-hand side. So I want to put them in order. So counting numbers, you start with counting. 1. Whole numbers, you add a 0. And then integers, you include the negatives. This is also, like, we're not going to do history of math in here, but this sort of mirrors the order that math stuff was figured out. Like, this maybe seems weird, but it was a while before they figured out that there was a 0. Which I guess makes sense, because if, how many sheep do you have? I don't have any sheep. Okay. How many sheep do you have? Well, let me count them. 1, 2, 3, 4. So counting numbers came first, and then someone came up with the idea of, we should put a number on how many sheep do you have? I don't have any. Well, that means you have 0. And then negative would come along after that. It's like, if you're just counting sheep, you never got the negative numbers. But maybe with money, like if you owe somebody money, then you sort of have negative money.
Or your sheep ran away.
Your sheep ran away and you're down 1? Exactly. So later they came up with negatives, and then later than that comes irrationals. Pi is a good example of an irrational. There's like one other main category of irrational numbers. Not repeating decimals, because repeating decimals would be rationals.
Huh? Oh, yeah.
But they're the ones that just go on.
Because they can be
0.3 repeating, because any repeating decimal can be written as a fraction. Any repeating decimal can be written as a fraction. In fact, you just put the repeating part over 9, and that's the 3 over 9 is, what's that?
Non-perfect squares.
Non-perfect square roots go where? Irrational.
So root 80.
Root 80. Yep, that would go there. 80 does not have a nice square root. Be careful how you phrase that. It does have a square root, right? It's almost 9, but it's not a nice square root, so it's going to have weird decimals after that. Usually we pick smaller numbers to give examples, but negative square root of 6. It has a square root, it's just not a perfect square root. What about fractions that are nicer than 0.3 repeating? Where does
2, 6, 1/2.
where does 1/2 go? Rationals, but it's not an integer, so 1/2.
What about
4 halves, that's kind of tricky because 4 halves is 2, so it seems weird, but 4 halves is a counting number or a natural number.
But then 5 halves would be irrational. Right.
5 halves would be rational.
Yeah.
Rational. That's right. Say it like that to remind yourselves what it is. Okay, imaginary. Or any other questions or examples you want to see, or any other numbers you think of you can't figure out where they go? When we talk about imaginary, it is I. It is I. It sounds like some declaration. Do you know what I is? Other than, it's imaginary.
Like impossible square root.
Impossible square roots. What do you mean by impossible square roots? You might be right.
Like no possible solution.
Okay, so what would have, like, square root of 80? Is that no possible solution?
No, because that's the solution.
Okay, so what kind of number are you saying would have no possible solution?
Negative. Oh yeah.
Hey, he definitely looked that down on page.
He may or may not have peeked ahead. That's fine. But yes, that's right. So we have to be careful how we phrase that. He said it's square roots that you can't do or impossible square roots. But now we're going to say that is a possible square root because we know what imaginaries are. So be careful how you phrase that. Square root of negative numbers, whether they have nice square roots like 1 or 100, or whether they don't have nice square roots, like if it's a square root of a negative number, it's imaginary. In fact, it's just by definition that the square root of negative 1 is equal to I. And so if the question in your mind is, where did that come from? It's a good question to have because the Council of Mathematicians long ago got together and said, you know what, we need to have a solution to this equation. If x squared equals negative 1, you're like, well, there isn't anything that you could square to get to negative 1. And up until you learn about imaginary numbers, you just say, oh, we can't do that. But they were like, nah, there's times in math where this shows up, and we'd like to have an answer. So if we square root both sides, we'd like to have like a name for this thing other than just saying, plus or minus, other than just saying we can't do that. And so just by definition, I is the square root of negative 1. So that's one where if you can't figure out where it comes from, that's an okay place to be because it was just made up.
So then what if that happens in like a slope equation or something like that? Like a parabola equation?
So that's a good question. You can't graph, like if you had 5ix plus 3 and you're like, oh, the slope is 5I, like that doesn't really make sense. Because this is a real number plane. We don't really say that very often. So that real number plane can't handle imaginary numbers. So it's a good question, it just doesn't, we don't deal with it. Or if it was a different kind of problem, like the slope was 3, but the y-intercept was 5i, like that doesn't, how do you do that? Well, you can't graph imaginary numbers on the real number plane. There is. There is. But it's actually easier because instead of an x and a y, it just has a real axis and an imaginary axis. We'll get to that later. It's much easier to deal with than like graphing lines and quadratics and stuff. It's usually just graphing points, so it's not really that hard. Okay, back to regularly scheduled programming here. If I is the square root of negative 1, and we square both sides, well, the square and the square root cancel each other out,
So it's just I squared.
and that gives us negative 1. I feel like we kind of reversed the order here. But that means I squared equals negative 1. I squared is negative 1. I mean, I know maybe it feels like one of those is backwards, but this is how we use them. Like if you see square root of a negative, you change it to I. If you see I squared, you change it to -1. Okay, so square root of -16. Soon enough, you're going to just spit out the answer to that, and it's easy. But let me walk you through it nice and slow to start with.
4I squared.
Just give me, well, some of you are right, some of you are wrong. So let me rewrite square root of -16 as square root of -1 times 16. We're going to really slow this down. Right? You're okay with that? But we could write that as the square root of -1 times the square root of 16.
Okay.
Yeah.
I'm not writing that stuff.
I know, you're not going to write any of these steps once you figure out the answer. What's the square root of -1? I. And the square root of 16? 4.
So it's 4I.
So my answer is 4I.
Shoot, I was right.
So the easier way to handle this is to, if there's a negative in the radical, you drag it outside and turn it into an I. So this becomes I square root of 4. Now 4 has an I square root. And we like the letter at the back rather than at the front. So 2I. I mean, it wouldn't be wrong if you wrote I2, but that's kind of weird. People don't write it that way. So you guys already turned the page because you know what the next two are. What's the square root of -49? 7I. And the square root of -25? 5I. And you're looking ahead, and these aren't good. These aren't good. Let's see. Turn the page. You know what we should have done as a warm-up is some normal radicals. So like off to the side here. How do you do, so before we stick the negatives in there and really complicate things, what do you do with the square root of 18? Yeah, the answer is 3 root 2, but you get there by taking out the biggest perfect square. So I'm showing a step that you probably don't show, but to show where it comes from, you could rewrite 18 as 9 times 2, and the reason you would split it up to 9 and 2 rather than 3 and 6 is that 9 has a square root. So 3 square root of 2. Let's see, what else could we do that's... What about the square root of 72? How could you split that up?
36.
Okay, I did pick this one because you do have options. You could do 36 and 2, because 36 is a square root. You could do 9 and 8, because 9 is a square root. But which one of those would be the better choice? Because you always want to use the bigger square root. So 30, or the biggest perfect square.
Or if you don't know, you can just do like a small one.
Now you're right, you could change it into 3 square root of 8, which is 2 root 2, which is 6 root 2. That's kind of the longer way around there. But you get there. And it is an okay thing to do if you get a big number and you can't figure out, like, what is the biggest square root in there? Like, well, I don't know, 9 works, so let's reduce by 9, and then check what's left. So that's the multi-step way. It'd be better if you could just get there the first way. Maybe we should review our perfect squares here. 4, 9, 16, 20, 36, 100. That's probably as far as we'll go.
100?
Not 121.
121, yes. 144,
Yeah, we had to solve
169, 196,
225.
there you go. 16 squared.
Is it 243?
You guys in computer science with your bits and bytes.
Oh, yeah.
256, 512.
We had to know all.
All right, so those, you're not going to need to know past 100. I guess I should write 100 down there.
Are we really? We were supposed to learn up to 30.
Well, you're not going to need to use them in here past there, I don't think. So, now back to square root of 20, but the first thing I would do is just take the negative out as an I. And then how would we break 20 up? Leave the I alone. 4 and 5.
2 root 5.
So it's like, well, what order do I put these in?
5?
Usually we put the I in front of the square root.
Oh, okay, so I got it right.
Well, I say that. It depends on the situation. Sometimes the I goes at the end. The reason we're nervous about putting the I at the end is if you don't draw your square root thing carefully, it might be unclear whether the I is under the square root or not. So if I intentionally drew that one ambiguously, you can't tell. But if you're racing through a math test and you end up with that, I'm like, oh, does he mean for the I to be under the radical or not?
You're definitely going to take less off.
Right. So those are my two options, like be mean and just take it off, or be like, well, I think he knew what he was doing, so, but I don't want to try to read your mind. I'm going to grade what's on the paper, so I'm probably going to be mean. But that's the reason you put the I here in front. That way it's pretty clear. There are times when you do want the I stuff separate, and if you do, then, make it obvious, or put parentheses on it and then make it really obvious. But this is the better way to go. Just put it right there. That way there's no doubt on where the I is. It's not under the radical. All right, 45. Same thing. Get rid of the negative as an I. And then what's 45? 5 and 9, so 3 root 5, 3I root 5. And these are the problems where we start maxing out our ability to skip steps, right? Like, some of you are going to skip steps to the very end and just tell me the answer. And if you can do it, fine. But you're doing a couple of things there all at once. You're taking the negative out as an I. You're splitting up the 32. And then you're square rooting the part that you can square root and then putting everything in the right order. Can you do all of that in your head? Probably. But I feel like once you get past 2 or 3 things in your head, you're really risking making some silly mistake that you don't want to risk making. So, having said all that, it's probably wise to show some of your work anyway. What's the square root of 32? 16 and 2. So 4I root 2. Again, could some of you, maybe even most of you, have gone straight there? Maybe, but don't risk it. Show something to keep your own brain in line. Not to mention, let me have a chance to give you partial credit. All right. Remember that we hadn't used this one since the last page. I squared is negative 1. We did that already, but we're about to use that. So this is the other way we use I. So what do we get when we square 4I?
Negative 16.
You're skipping steps on me. You're right. 16I squared, right? Square the 4, square the I. But I squared is negative 1. Go overboard here. And my favorite wrong answer for this one, for people who would go overboard on showing their work, they write 16 and minus 1, and they say that answer is 15. You're like, oh, you did all the right stuff until you're multiplying, not subtracting, so negative 16. Okay, let's see. Speaking of showing your work, what is the square root of negative 9? 3I. And the square root of negative 25? 5I. Okay, now we can jump to the end. What's 3I times 5I?
Negative 15.
Positive or negative? Negative. 15I squared, which is negative 15. 5I times 6I? You could probably jump to the end on that one. Negative 30. Because I squared is negative 1. Okay. Again, we should have done maybe some warm-ups where you had 5 over square root of 3. What would you do to fix that?
Root 3 times.
Root 3 where?
At both the top and bottom.
Both, top and bottom. So that would get you 5 root 3 over 3.
So do we do
No i's or radicals in the denominator. Like, this is a little bit repetitive because an I is a radical. Like, it doesn't look like a radical, but I is square root negative 1. So I is a special type of radical, so it is also not allowed in the denominator. So Ryan, what would you like to do to fix this one?
Is it by I or just 3I?
Okay, that is a good question, and the answer is either one works. I or 3I.
I'll do I.
But if you do 3I, you're going to have to reduce things later. So the only thing that's broken is the I, so let's just fix the I. So 5I over 3I squared, but that would be negative 3. And then that's fine as an answer, but usually we like the negative out front or in the top. Right, you can move the negative wherever you like. You can put it in front, you can put it in the top, you can put it in the bottom. Well, that next one looks a little bit tricky. Let's simplify what we can first. What's the square root of 20? 2 root 5. And in the bottom I've got 2I root 5. Well, before we start fixing things, those things are multiplied. So when you say attached, if it's attached with multiplication, that's great because then you're allowed to cancel. So I can cancel the 2's and the root 5. Now, be careful. What's left?
0I. 1.
Okay, well, it's not just I. We know that. That's another favorite
0
mistake.
over I.
You keep telling me 0. What's 3 over 3 equal to?
1. How's that 1? You just cancel that 1.
Yeah, and 3 divided by 3 is 1.
Oh.
So 3 over 3 doesn't turn into 0.
So it's 1 over I.
So it's 1 over I. Which, that's not a final answer because we got I in the bottom.
1I over the negative.
So let's multiply by I over I.
So it's just negative I.
So I over I squared, which is I over negative 1, which looks kind of funny when you could just say negative I. Let's do one more of those.
How come I?
I don't like that. I don't like that either.
It's pretty easy.
Whoever had this had a terrible imagination.
Let's do 3 over square roots.
I was trying to make it hard for you.
I am trying to make it hard for you.
Just do the homework. There's a hard problem on there.
Is there a hard problem on the homework you found? Let's do that then. Probably.
Oh yeah. There's
Number
17.
All right, and hey, there's a back too, so that's fun.
Oh, let's go.
17, that's a good one. Well, let's do. Goodness, we're yelling at me now.
Hey, I think they're all photomath. I'd take back 17.
27 to 28.
30. You're one of the ones where it's like all square.
Let's start with 17 before we get to the crazies on the back. So, 17. What do you want to do first on 17? There's simplify what?
24.
The square root of 24?
Oh, and square root of 8.
Okay, here's a bit of a trick. If they're both under the square root, you can simplify the 24 and the 8 like together. So rather than changing 24 into 2 root 6,
6 and 2, or 3 and 4.
you could just reduce the 24 and the 8. 24 divided by 8 is 3. Root 3 over 3i. If they're both under the radical, you can do that.
That makes it.
Oh, that's kind of weird. That's kind of.
I mean, we're not done yet, but that does make things easier, yes. So times I, top and bottom. Again, I'm going to put the I in front so that it's clear. Not under the radical. And the bottom becomes -3.
So excited for Christmas.
How about 19?
I don't know. I feel like 27.
We'll get there. 56 and 7.
It'd just be 8, right?
That would be 8.
8 over -1.
But let's say it's root 8 over not -1. That'd be root 8 over I. Which, well, maybe you got the right answer anyway here. Because when I multiply by I, so it would be I root 8 over -1. But that looks kind of funny. We don't want to leave that. Let me just say it now. If you leave that, I'm going to take off 1 because that annoys me if you put something over -1. So -1 for annoying Mr. Wolf.
Yeah.
That's good point. Wait, why wouldn't you simplify the 8?
Oh, good call.
Oh.
-1 for leaving it that. Maybe -2. What does 8 become?
2 root 2.
2 root 2. 4 and 2. So let's see if we can put all the things in the right spot here. -2I root 2. Yeah. Okay, let's get to the ones you're eager to look at here. I know, there's so many exciting problems on the back. Goodness, I don't even know where to start.
We just do all of them.
Let's do all of them. We're not doing all of them.
I'll stay here. I don't want to go something. 27 is.
These are things that happen later in math life. Like, I can tell you, like, where you will see these again. And so we're wanting you to be able to handle the algebra part of them when you get these. These are answers to pre-cal problems, most of these. Most of these are answers to pre-cal problems.
Oh, so I should take a picture of this?
But that's not the final answer because we want you to simplify things.
In pre-cal. Yeah. Look for us.
So let's do 24.
That's not doing that.
Let's do 24. Do you remember how to fix 24?
Yeah, you can kind of just like divide the radicals, right?
You can only divide things that are being multiplied. So don't be saying root 3s and 1s.
My bad.
Do you remember how to fix this? What we can multiply by to fix that?
A number.
A negative.
Root 3.
Negative is sort of right.
Sort of right.
Negative
That's
1
good.
or negative root 2.
Maybe you haven't done these yet.
No.
Conjugate. You multiply by the conjugate?
What?
Oh, okay. Well, that's why we're doing this one then. If you change the middle sign, it's called the conjugate. And the reason you multiply by a conjugate...
So is it just, you just change the bottom? Yeah.
Correct, because the bottom is what we're trying to fix.
Oh, okay.
Right? We don't care. The top can be ugly, that's fine. But the bottom we need to fix. So let's FOIL this and see what happens. It's going to look ugly. Let's FOIL the bottom first, because that's what's motivating us to multiply by the conjugate. First, outside, inside, and last. Something always happens when you FOIL conjugates.
The radicals cancel out.
The middle terms cancel out.
So just 1 minus 3.
So you guys that don't do the middle terms when you FOIL anyway, congrats, you're in good shape here. The O and the I will cancel out. So that leaves us with -2 in the bottom.
Wait, after you showed it?
Every time.
I gotta think about it.
Oh, because it's 1 minus 3.
Because you change the sign and sort of force that to happen.
Oh, shoot.
Oh, no, I'm thinking about the one.
Oh yeah, 1 minus 3. Spot you a calculator on that one. If you had 1 sheep and 3 of them ran away, that'd be tricky to do. I get it. in the top, I still need to FOIL the top. So root 3 first, outside, inside, last. Careful with all the multiplying in there.
They don't cancel out.
They don't cancel out. What's root 3 plus root 3? 2 root 3.
2 root 3 minus 4. Or
So
minus 4 plus 2 root 3.
usually we put the number first. So negative 4 plus 2 root 3. That's
the negative 3. Oh, I see. The radicals.
Yes, the two radicals multiplied together to just give us 3.
So I think we should. This should be a challenge page.
So, Mr. Wolf, is
And we're-
there ever going to be a time when the radicals aren't the same? If you multiply like an 3.
Yes, I don't see it happening on this page.
Okay.
22.
So there's a chance it doesn't simplify to be a 3.
Wait a minute, we're not done with this problem yet.
Oh my goodness.
I can divide both of those by negative 2.
You sure can.
What's negative 4 divided by negative 2?
2.
And 2 plus root 3 divided by negative 2?
2 plus root 3.
Minus root 3.
So minus root 3. The 2's cancel, but there's still a negative there, so negative root 3.
I have nothing.
Wait, you said you can divide this by negative
2 divided by negative, here's just 2 divided by negative 2 is negative 1.
There weren't even imaginary numbers.
There we're not, you're right.
2? Wait, I'm lost. How did you get the 2 root 3?
What?
Yeah, I genuinely have no idea.
Oh, he added the 2 root
2 root 3 came from root 3 plus root 3 is 2 root 3.
Oh.
1 sheep plus 2 sheep. 1 sheep plus another sheep is 2 sheep.
Yeah, look at
Okay, got it. Thank you.
Okay, which one are you wanting to look at?
none of them.
26, 28, or 30.
26, 28, or 30? Although I guess
Or 29.
30 looks better because it doesn't have a square root in there.
29 is 5.
Fractions are all extra.
So 29, is that...
It's a triple fraction.
Janji, how do you type pi? I just need to know that.
Pi over 4 divided by 2?
Is that just time?
It is times 1/2.
5 over 8.
So it's pi over 8. Half of a fourth is an eighth.
Oh, so that's it?
That's it.
How'd you, where'd you get 1/2?
But you're gonna, a bunch of people are gonna put pi over 2 for that answer.
I'm just going to put that.
Where did you get 1/2 from?
Keep it, change it, flip it.
Because divided by 2 is the same as multiplying by 1.
I had KFC last night.
Jackson.
It was delicious.
KFC is not, like, out of all the choices of cheesecakes. Wow.
I don't know. It's not my favorite, but it's my middle child. He's on a KFC kick right now, and for whatever reason, he got to pick last night, and so KFC it was. Okay, we still need to do one of those ugly ones over there.
Wait, is that
Yeah, dealer's choice, right?
26 or 28, I'd say they look pretty similar, so it doesn't matter to me. 30's better because it's the same thing, but it's not under a radical.
Why
So
do you have to pick 25?
Let's do 26. Does that have a negative?
26 has a negative. Okay,
Square everything.
26 has a negative. I guess it has a negative, but it's minus a negative. So that's 1 plus 24 over 25.
And can't you just...
Can't we just what?
No.
Let's see. Let's go one step at a time here. How do I do 1 plus 24 over 25? How do I add fractions?
You find the
Common denominator.
25 over 25. So that'd be 49. 49 25ths.
49 25ths
But they're all
over
perfect
2.
squares.
Now they're all square rooted, so we got to handle
Two is
that.
not a perfect square.
No, but it's
top was.
So 7 over 5.
So that's 7 over 5. That's right. Let's be careful, though.
Oh, yeah.
You're right. It's 7 over 5.
And then keep it, change it, flip it.
And what's in the denominator?
Radical 2.
Radical 2, right? Square root of 49 and 25, that was easy. I couldn't take the square root of 2, so that's still there.
Ooh, so now we do the multiplication thing. We have to get in the denominator.
I'm going to assume what Cooper was trying to say there is keep it, change it, flip it, and do that.
Sure, that works.
Is that what you meant? Maybe?
Well, I was thinking take the root 2 and like multiply it up because that's what we do.
Yes.
When you get the denominator out.
Yeah.
That's what you need. Yeah.
So the top is 7 root 2. Ooh, what's the bottom? I'm short on space. Can we do all that at once?
Oh.
10.
You can't just
10, it's not 20.
Hold on, where's the root 2's? Oh, I see. Never mind.
I got 7.
7 root 2 over 10. I didn't randomly multiply. What am I randomly multiplying by that you're worried about? Which 2?
The red ones.
The red ones? The red ones? Why are those red root 2's on there? What am I doing?
Take the root 2's out of the denominator.
I'm fixing that root in the...
Where'd the I go?
There wasn't any I in that because we didn't square root a negative.
That's the whole point.
Why is this finally?
In fact, there's not any I's on the back page at all.
I just don't know what I'm ever going to I don't even know what I'm doing.
I'm sure there's no I's on the back.
So do we have to do that?
So, yes, you need to work on that. That's today's assignment. That's a lot of stuff. All of it. Although, come on, some of them will be quick. We'll have time tomorrow to answer questions on it.
You can't say yes or no to that.
I will not complete the work. I'll be at home working on this. So I just have to type 5 and
Shoot, you're right.